Hello all YouTubers, I am the Weather Dude. Welcome back to my YouTube channel. Thank you all for tuning back into this weather presentation for April 22nd, 2020. As always, please consider subbing and liking to my YouTube channel for more weather content, exclusive weather content. And as always, please consider viewing my website down in the description below. So today we're going to be talking about a major pattern change involving stormier conditions for the eastern U.S., especially the northeastern U.S., and warmer and drier conditions for the western United States. So we're going to get into that today. When we're looking at the 500 millibar height anomalies, we're going to have two models to look at, European and the GEFS. And also kind of a little, just for fun, question about global warming at the end. So please stay tuned for that as well. So the European model here, again, here's that big storm that kind of produced some of that severe weather, okay, on yesterday on Tuesday. That is going to race its way on out of here, and it's a very big storm. Okay, so its wind effects are going to take a little while to leave. And again, we got your ridging, all right, but the ridging, the gesturing kind of goes down like this. So here's your next little trough, your little low pressure system here. Okay, this is the European model, and watch is going to grow as it moves to Missouri. It grows some in size, but it does grow some in strength as well. All right, this is again. Here's your trough. All right, and you got some of here's your ridging. Okay, so that's why the West Coast could be lacking precipitation. Okay, over the next few days. And then as it moves into the east, it kind of weakens. All right, I mean we kind of have the atmosphere dynamics don't really support it, but we still got that little storm. But it still will affect the mid-Atlantic heavily, as well as the Northeast, with some potentially heavy rain. And then keep an eye back here. Here's your next trough, kind of forming on back here. And again, that ridge is kind of it's moved even closer now, so it's starting to move towards the West Coast. It's kind of keeping California dry. And so again, here comes that second system. Okay, so this is why the Northeast is going to be pretty stormy. And your next trough. Also keep an eye up there towards Alaska for potentially another storm system. And here's your high pressure system. Okay, and the ridge goes all the way up into Canada. So we're talking about forcing air all the way up into Canada here. And that's going to help the jet stream take a big deep plunge. And that's why that storm's going to form right here. And again, where there's a raise, there's always got to be a drop, like a roller coaster. And that's what you have up there towards the top left of your screen, up into Alaska. All right, and then that storm really grows here. So big time trough here. As the low pressure moves over the mid-Atlantic, it will be out of here by Monday morning. Will be affecting the area Sunday. Maybe some lingering effects, wind effects potentially on Monday as well. But again, there's your high pressure system that's sitting over the southwest. And we do have actually they're sort of connected. There's another high pressure up there, top right of your screen up there in Canada. And again, with every raise, there's got to be a drop. So here's your troughing up there into Canada. All right, let's continue to move on here. And this is just a complete dynamic storm setup. You have your classic ginormous trough in the west, okay? Ginormous high pressure. I'm sorry, I didn't mean to say trough. I meant to say ridge. We have a ginormous ridge over the center of the country and west coast of the country. And then you have your huge low pressure system with that trough right here. Okay, Justin takes a big dip, and the east is going to be stormy. Okay, like I said, that storm is really big in size, so it's going to take a while. I mean, it could start affecting parts of the east potentially Wednesday afternoon, potentially, and maybe not even leaving or having some lingering wind effects or rain effects by Friday afternoon. It might be scooting its way on out of here, and then you can see it kind of starts to flatten out. Sort of calm down. Okay, again, we're talking about 9 days out at this point, but the ridge does seem to flatten out a little bit. Okay, so we're not talking about huge ridging and huge troughing. So keep things pretty calm across much of the country, with the exception of the northeast there, maybe parts of Montana due to that little low pressure up there. But things will start to calm down. Okay, and eventually, as the European model depicts it, there's going to be a high pressure in the center of the country. It's gonna be a flat jet stream, so its effects are going to go from coast to coast here. We're going to be pretty calm, except for some potential wind hazards in Maine, as well as the West Coast. We're going to next incoming storm system. But like I said, because that jet stream is kind of flat, it's could be hard for a big time storm to develop, and then that would eventually push the trough eventually down here potentially, if that were to happen. So high pressure eventually could have some effects coast to coast. All right, here is the 500 millibar heights. So I kind of want to skip here to that dynamic storm that I showed you on April 30th. Take a look at its effects here. Here's your little low pressure center. Okay, and that's a big time storm system here. Okay, again, that's about Wednesday at 8 p.m. and it continues to move to the east, and then eventually everything comes down. But again, we can still have some wind hazards up in the Maine, even 10 days out. So even Saturday morning, we can still have some wind hazards or some clouds hanging around. Take a look at the temperatures. Okay, that dynamic storm that I showed you is going to lead to some pretty cold temperatures. All right, take a look at the high temperatures. Okay, this is 2 p.m. on Wednesday the 29th. And take a look at the Northeast. Our high temperatures are in the low 40s. All right, but here's what I also want you to notice. Take a look on the back side of that low, the immediate backside. This thing is very tight and wound up. Because you think, well, if we're behind the storm system, why isn't, the northern plains so cold? Well, that ridge, okay, is really starting to build in right behind that storm system. So, although behind the immediate storm system, okay, like a place like Chicago, your high temperature is going to be 40 degrees. But if you go on that eastern side, so as your cooler side, but on that front end of that storm system, Pittsburgh has a high of 66 degrees. All right, so when you have that sort of spiral action like that, there's your low, there's your backside, your cooler conditions, there's your warm air getting thrown up in, there's your zone, that northeastern part. So that's what we're going to be watching for. And yes, the southwest could get into the hundreds. Before this was probably in the hundreds. Well, the hundreds actually. Yeah, there you go. Right there. Oops. I always miss it, don't I? There we go. 105 degrees. 106 actually, according to the European model. And that is Sunday at 8 p.m. So, yes. But overall, temperatures will be pretty cool for the Northeast. So we're going to have some cooler conditions potentially lying ahead. Temperature anomalies, again, with that dynamic storm system that I showed you on that back side, we're talking about 15 degrees below average for Indiana by 8 p.m. Wednesday. But look at the West Coast, 10 to 30 degrees above average with that huge amount of ridging. And like I said, once that ridge starts to sort of calm down, all right, we're still 26 degrees above average, but that area's kind of shrunk. So a lot of places are more, 5 to 15 degrees above average. Not like a widespread area in the West of 20, 30 degrees above average, although there is still some of that. Okay, the ridge is starting to flatten out a little bit. We're not quite as, severe. Okay, we got some cooler conditions up in Canada and some warmer conditions to the south, although they could get a little extreme at times. Here's your precipitation according to the European model 10 days out. And watch the East Coast, okay? From Delmarva all the way through Massachusetts. Talk about 4 to 7 inches of rain in the next 10 days. Normally, we see about 2 inches or so. 1.5 to 2.5 inches in we usually see 1.5 to 2.5 inches in a 14-day period. And this is over a 10-day period. So something definitely to watch here. But anyway, I mean, even outside of that, in the red, that's 2 to 3 inches of rain in a 10-day period. Like I said, this area usually sees about 2.5 inches maybe in a 14-day period. So if you're in that red color, and this actually does play out like the precipitation on this model forecast, anywhere in that red zone in the eastern part of the country, that you could be classified as above average precipitation, because 2 to 3 inches is what we normally see in 14 days, not 10. All right, here's a GEFS model, and again, there's storm number 1, moving through eastern Pennsylvania, Delaware, Jersey, kind of weakens by then. It's a lot stronger back in Missouri. Then here's your next storm system. Okay, again, it has a pretty strong. Here's your next trough. Okay, and notice the ridge does go up pretty far. So again, there's your next ridging pattern coming across the southwest. Okay, and then boom, there you go. Again, here's your dynamic setup. Huge trough, huge ridging into the west, huge troughing in the east. This is your classic dynamic storm setup. All right, and again, temperatures are going to be into the 40s, even in the heat of the day. All right, upper 40s, low 50s, still some pretty cool temperatures. again, we're heading into early May, so we should, in the Northeast, we should pretty much be in the 60s and even close to 70s by then. All right, so the the troughing pattern will keep us cool. All right, cool and wet. If only we had that during the winter time, huh? Kind of use the snow down here, but it's kind of late for that. All right, I mean, even though the Mid Atlantic here, we had a couple years ago, back in March of 2018, we had those big snowstorms. Two of them. One brought 10 inches, one brought 12 inches. The one that brought 12 inches, again, as some of you famously know, as the spring snowstorm. So it was the first day of spring. Actually, the second day, the first full day of spring. It was really the second day of spring, and that's when we had 12 inches of snow. And even then, we're talking about the end of March here. Even then, it was hard for the snow to stick, at least on the roadways. So if it tried to snow a month after that, I doubt it'd be able to stick at all. It could fall, but not stick. All right, it was even hard for it to stick in March. So even though, like I said, it all depends on that sun angle, the way that sun angle is positioned. Let's take a look at the temperature anomalies. Again, when that dynamic storm comes through, all right, so let's take it. So again, the GEFS does put some pretty intense. I mean, we got 10 degrees below average in the east, 10 to 20 degrees above average in the west with that ridging. Even before that, all right. Again, here's more ridging, all right. So you can almost correlate the pattern as like this. So if it's more above average in the west, it could be more below average in the east. So that kind of makes sense. So if we have like 10 degrees above average out in the west here, maybe the east has 5 or 10 degrees below average. If we had like 30 degrees above average in the west, then we maybe could have 20, 30 degrees below average in the east. So if the anomalies grow here, they're also going to shrink down here. So again, it's all depending on that. Because remember, you could have it set up like this, but it's kind of rare we have a huge ridge and then a tiny trough. All right, chances are, if there is a high ridge, there's going to be a very low trough, and that's how your storm systems are going to be forming here, at least in the east anyway. Thank God that the southeast could potentially be talking about some dry conditions. I'll talk about that right after this map here. GEFS ensembles from Missouri through New York. They have a little area. This is, now keep in mind, this is 16 days out. All right, so let's go back to 10 days because that's what the European model was going, so we can kind of compare fairly here. A few scattered areas of yellow, so maybe 4 inches of precipitation. Then going out 16 days now, so another 6 days, and 2 to 3 inches from southern plains all the way up to the northeast. And again, embedded within that is your kind of 4 to 6 inch zone from New York, again, back west towards Missouri. Now, here's your 6 to 10 day temperature outlook from the Climate Prediction Center. And again, at least 70% chance of cold conditions up in the northeast. And again, there's your troughing. There's your troughing. There's your ridging in the southwest. So we could be getting into the hundreds, places like Arizona, Death Valley. But the precipitation, look how the southeast, it's kind of getting a little bit colder. I mean, drier, sorry. It's getting pretty dry. But yes, it will get kind of chilly, as you saw in the temperature outlook. But like I said, even though the pattern change will be for storm here in the east, ridging in the west, like I said, I was emphasizing the northeast because that's where the northeast is really going to be seeing that above average precipitation. But that doesn't mean that the southeast won't get a storm. Thank God it won't be as severe as it has been before. Now, the 8 to 14 day temperature outlook, again, pretty much same story. Northeast, 50, 60, 70% chance of colder conditions. So if we see warmer conditions building into the southeast, that means that ridging will build in and potentially some drier conditions. Now, warmer conditions doesn't always mean dry conditions, but in this general situation, that's what it does kind of mean. And just south, from DC point south towards the southeast here, potentially up to a 40% chance or a 40 to 50% chance of dry conditions. So again, this is good for the southeast, but it's not good for Florida because Florida, especially the peninsula there, not so much the panhandle, but definitely the peninsula does need some precipitation. They do need some rain. They've just been really lacking it down there. Southern Plains, again, we have a slight chance of above average precipitation, as well as the Northeast. You can't really see that because of the camera. But again, that ridging in the West, definitely some drier times. All right, now let's get into the more fun stuff. So global warming, all right? You know how global warming means increase of temperature. That's, I mean, whether you believe it or not. I mean, if global warming, I mean, I myself do think that global warming is real. It is a problem that we are facing right now, okay? And there's no judgment. You believe it or you don't believe in it. I mean, there's no judgment zone here. But let's say that global warming does actually exist and the temperatures do go up, as well as the precipitation may go up in parts of the east. The precipitation will probably go down in parts of the west. So that's how it's kind of shaping up here. So let's look at the precipitation first. All right. And this is kind of like the climate prediction center NOAA. Allows me to make my own maps here so I can kind of show you guys kind of like so this is the 60s, all right? Beginning to the end of the year, 1960 to 1970, so call us the 60s, all right? So each year, how much precipitation are we averaging? All right, you look out in the west, some parts of the west here only average about 10 inches of rain every single year during the 60s, all right? But take a look at the west coast, and yes, we average about 50, 60 inches plus. And same thing for the southeast. We average between 50 and 60 inches of rain, or at least precipitation. But look at the northeast. I want you to focus on the northeast because that's where we're going to see a lot of changes over the years. All right, 60s, 70s. Notice how the northeast has a lot more blue, and even the southeast. We're starting to get more dark blues to the southeast. So no more 50 to 60. We're talking about over 60 inches of precipitation each year, on average, through the 70s. All right, so we're talking about just the 70s here this time. And again, the northwest coast pretty much stays the same, Washington, Oregon, and the west here just doesn't really get much. Talk about 5 to 20 inches of precipitation. All right, you can see wetter east, drier west here. All right, but again, watch the northeast. All right, now let's go to the 80s. All right, again, pretty much the same, maybe a little bit of a drop, but the southeast definitely stays the same, as well as the northwest coast. The Rockies does stay the same as well. Again, there's not going to be no astronomical change, but like take Utah, for example. The orange has actually faded off a little bit. So a little bit more precipitation for a place like Utah, but overall, take a look at California. Notice how the reds are kind of strengthened a little bit. A little bit of strengthening in the reds there. So 5 inches of precipitation every year. I mean, Death Valley, I mean, that's kind of true. Actually, it is true. All right, now here's the 90s. Again, the Northeast, still staying the same, but I want you to watch them when we get to the 2000s. But for now, here's the 90s. Again, the Southeast, kind of leveling off, but still increasing that precipitation, decreasing it through the West, definitely. And even the Northwest coast is still, but they've always been wet. That's because they're on the Pacific coast. That's normal. But when I mean the West being dry, I mean like away from the coast, like this kind of West. Like the Intermountain West. But still, the West Coast could be getting drier due to global warming. All right, notice how the reds really take on their strength here across the West as we head into the 2000s here. 2000 to 2010, you saw a lot more reds going up, didn't you? Yep, precipitation goes down, and guess where it goes up? Right over the Northeast and the Southeast. And actually, the Northwest Coast actually decreased a little bit as well. Like look at them back in the 60s. It was all dark blues. Here it is now. Starting to see more medium blues working their way in there. So it's evidence, okay? I mean, precipitation is potentially going up across the east, potentially going down across the west. Before I go to, now I'm going to show you the same maps with temperature, but before I do, I want to show you the PNA index. What the heck is that? I know what you're thinking. All right, but before I explain it, I want you to know that the PNA could be going into the positive zone, all right, by the 1st of May. That's where it could be climaxing. Peaking, and this kind of correlates with what I was talking about earlier with the all the troughing patterns and the pattern change. This kind of backs me up here, sort of. If we're heading into a positive PNA phase, all right, notice how we have increased ridging in the west, more atmospheric pressure, as you can see right here, and the east and the southeast is seeing less atmospheric pressure. Again, check out the winds here. Again, low pressure. Notice how the winds flow counterclockwise. Take a look at that wind arrow going west to east. So that's going west to east, and then low pressure, right? If you're on the eastern side, the wind's coming out of the south. Well, take a look at that wind. So the jet stream is going like this, all right, and then it comes down, and that's what happens in a positive P and A phase. All right, and that's what could be potentially happening over the east. Now, sadly, notice how we didn't have much of a P and A phase through the winter. That could explain why the East Coast had such a bummer winter. I'm disappointed. I didn't get to use my sled. That's okay. And even actually in January, we actually had a negative P and A phase multiple times. And what you see here in the, I mean, it's pretty simple. Whatever you see here in the positive P and A phase, just picture yourself in the opposite situation, and that's what it's going to be like for a negative phase. Okay. Unfortunately, I couldn't find a map for the negative phase, but whatever you're in right now here, just picture the opposite and that's what would happen if you were in a negative phase. All right. Here's the temperatures. Now you got to keep a sharp eye, okay? Because while I'm flipping maps, I mean, I'll be pointing them out, but it's gonna be hard to notice changes. But there are changes in the maps. But I want you to be vigilant and look at the changes, especially in this zone. That's where we're gonna be seeing the most changes. So keep an eye on this zone here. But again, anyone that lime green color, and now remember, these are the average temperatures from January to December through the whole year. Okay, and this is the 60s. Now remember. You might be thinking, well, why is the eastern seaboard say 40s, 50s? What about the summer? Yes, this takes into account all the winter temperatures. Basically, we took the temperature of every single day, 365 days in a year, okay, for 10 years, take the average, and this is what you're going to get. All right, so kind of cutting the layers here. We have your lime green region here. That's sort of, 40 to 50. We have your even like teal regions, which is like 30 to 40. Okay, then you got your sort of 50 to 60 region, and right here you got your 60 to 70, and then down Florida, Texas, Arizona, that's your 70 to 80 region. All right. Now I'm gonna go to the 70s. This is the 60s. Now here's the 70s. Now notice there's not gonna be much change here. All right. This one you won't notice that's much change, but notice how the oranges have sort of kind of moved up northeast a little bit. So Carolina right here. I want you to watch Carolina right here and right here. Notice back in the 60s. All right, and here's the 70s. So a little bit more advancement in the orange. Take a look at Florida. All right, that's 70 to 80 temperature region. Watch Florida right here. I'm gonna erase all the black dots. I want you to focus on this black dot. All right, watch how the 70 to 80 region moves one county to the north in Florida. So yeah, those are counties. Well, actually, those aren't counties, but yeah, it definitely has moved a few counties to the north. So now much of the Florida Peninsula is engraved, or what's the word I'm looking for? Captured in the 70 to 80 range, but still, southern Texas, western Arizona, Florida. That's what I meant to say. Engulfed. That's the word I was looking for. So much of Florida now is kind of engulfed in that 70 to 80 average temperature throughout the whole year. Like I said, average temperature throughout the whole year for 10 years. Take all the averages of that. This is what you're going to get. Now, this is the 80s. Notice how the oranges are starting to fill in more for the southeast. And also, before we started this, there was no yellows in the Iowa. Well, look where they are now. So again, I'll go back all the way back to the 60s. Here's the 60s. Here's the 80s. All right, so the orange is starting to spread out a little bit more in the desert southwest. Oranges move up a little bit, so do the yellows. Although the eastern seaboard does tend to stay the same. Here's the 90s. All right, again, a little bit more of a move up here. And notice how that 70 to 80 region, it's almost at Virginia at this point. I mean, before we started, it was barely in North Carolina. Now that 70 to 80 region is almost in Virginia. All right, and here's the 2000s. 90s, 2000s. And that darker orange region really expanded there for Arizona, but stayed the same for Texas and Florida. But again, here's the 2000s. Now, like I said, this was 2000 to 2010. I could have gone 2010 to 2020, but because 2020 is not over yet, the data would be incomplete. So once 2021 starts, I'll add a new map if I do something like this again, and I'll be like 2010 to 2020. But since it's not over, I can't really show that yet. The data would be incomplete. So here's the 2000s. Here's the 60s. 2000s. So that medium orange really lifted up over the years, over like 40 years. So, like I said, these are signs. Like I said, no judgment zone. Do you believe in global warming or you don't? I mean, everyone's got their views on it. But thank you for watching. I hope you understand a lot about the pattern change and coming for the United States. And I hope that you enjoyed the little experiment that I kind of got together for that global warming thing. So, thank you guys for watching. Stay tuned for the next video. I'm the Weather Dude, signing off. Till next time. Thank you for watching.